Hello everyone. Today we are going to see Class 8 Science, Chapter number 3, Force and Pressure. In that, we are going to see today numericals. First, we will see the explanation for the solved examples given in the textbook, and then we will go towards the unsolved examples given in the textbook. When we see the first example given to us, in that they had asked to us the area of the bottom of a tiffin box is 0.25 meters square and weight is 50 Newton. Calculate the pressure exerted by the box on the shelf. So first of all, they have given us area, then weight of the box they have given, and the pressure we have to calculate. We know the formula for the pressure, that is pressure is equal to force upon area. So 50 Newton upon 0.25 meter square, and when we will solve this calculation we will get 200 Newton per meter square. Now the second example, calculate the relative density of iron if the density of water is 10 raised to 3 kg per meter cube, means kilogram per meter cube, and density of the iron they have given as a 7.85 into 10 raised to 3 kilogram per meter cube. So given, we can write, first they have given as a density of a water, that is 10 raised to 3 kilogram per meter cube, density of iron they have given, and then the relative density we have to find out. Relative density formula that already we know, density of substance upon density of water is nothing but what? The relative density of particular substance. So that is the 7.85 upon 10 raised to 3. So this will get cancelled and what will be left is a 7.85. Next part is, or the next question is, third example. The area of the tip of a screw is 0.5 millimeter square and its weight is 0.5 Newton. Calculate the pressure in Pascal, means in a MKS unit we have to calculate, and exerted by a screw on the wooden plank. So first of all, area we will convert into meter square, and when we want to convert millimeter square into meter square, we have to multiply it by 10 raised to minus 6. So this 0.5 into 10 raised to minus 6 meter square it will become. Then weight of the screw is a 0.5 Newton. So weight upon area, that we know very well about the pressure. So it will be 0.5 upon 0.5 into 10 raised to minus 6. So here what will happen, 0.5 will get cancelled. If I want to show this calculation, and I can show over here what we are having. We are having 0.5 upon 0.5 into 10 raised to minus 6. So when we will cancel this, we will be having 1 upon 10 raised to minus 6. And when we will write this, it will become 10 raised to 6 and the unit will be Newton per meter square. Now let's go towards the next example. Example number 4. Mass of a block of metal is 10 kilogram and its dimensions are length 50 centimeter, breadth 10 centimeter, height 20 centimeter. If the metal block is placed on the following surface on the table, find out which of the surface with the A, B, C, D, C, D, E, F and B, C, F, G will the pressure exerted on the table be maximum. Means we have to find out which surface will produce a more pressure on the surface of the table. Now here, first of all, weight of the block they have given in the So we have to calculate weight of the block mg, 10 into 9.8 Newton. 9.8, that is the gravitational acceleration. So we are getting 98 Newton. For the surface, ABCD length is 50 and the height is 20. When we talk about this ABCD, this one, length is 50 and the height is 20. If this face is on the surface, then 50 into 20, that is area is a 0.1 meter square, and when we will calculate 98 upon 0.1, we will be having a 980 Pascal. Same way for the other surface, if you want to calculate it, CDEF, length is 50 centimeter, breadth is a 10 centimeter. So pressure formula that we know, 9800 upon 5, and that gives us a 1960 Pascal. Same way about the BCFG. There also height is 20 and the breadth is 10. And then calculation will give us a 4900 Pascal. Means the maximum pressure is for surface BCFG. Now the next one, example number 5. A piece of marble tile weighs 100 gram in air if its density is a 2.5 grams per cubic centimeter. What will be its weight in water? So what we will do, first of all we will write the given things what they have given to us. They have given to us as a weight in air, that is 100 gram. Then density they have given 2.5 grams per cubic centimeter. Then the volume we can find out, that is a mass upon it's nothing but what, mass upon volume is nothing but the density. So volume is 40 cubic centimeter. Therefore, according to Archimedes' principle, when the piece is dipped in a water of volume equal to the volume of the piece, that is 40 cubic centimeter, will be displaced. The loss in the weight of the piece will be equal to the weight of displaced water. So weight in a water, 100 gram minus 40 gram, and that will be equal to 60 gram. Let's go towards the unsolved examples given in the chapter. First, they have given us the question number 5, complete the following tables. In that, mass, volume and density. On this particular, we have to calculate and get the results. So first part they have given as mass they have given, volume they have given, density we have to find out. So as we know, density is equal to mass upon volume. This formula only we have to use. So mass they have given, that is 350 kg upon volume is 175. So when we will divide it, we will be getting 2 as a density. And 2 will be in a unit kg per meter cube. So this is about 5.1. Let's see the second part of this. In the second part, they have given us volume and density they have given. Volume and density they have given. So we will calculate it again. Formula is the density is equal to mass upon volume. Density they have given as 4 and volume they have given as 190, and mass we have to calculate. So we will write over here mass. Therefore, mass is equal to 4 into 190, and when we multiply it, what will be getting? 19 fours are 76, so 760 kilograms will be the mass of the particular object. So this is about 5.2. Now let's see the next part. In the next part, they have asked about density of metal, density of water they have given, and the relative density they have given. We know the formula about the relative density. When we talk about the relative density is equal to what? Density of substance upon density of water. I'm writing in a short, you can write in a full in your notebooks. So here in a first question, what they have given? Density of water they have given, that is 10 raised to 3. And on the other side, they have given as relative density as 5, and we have to find out a density of substance. So density of substance will be this cross multiplication we can carry out, that is 5 into 10 raised to 3. And as we know about the density of metal, instead of substance you can write as a metal, because metal they have given. So unit for this will be kilogram per meter cube. So this is about your 5.2, the second table in that first part. Now let's see the second part. In that they have given as a density of a metal 8.5 into 10 raised to 3, and density of water also they have given, and the relative density we have to find out. So directly formula we can use. Formula I am not writing because that you know very well. So directly the substitution I am doing. What we are going to have, density of the metal, that is 8.5 into 10 raised to 3 upon density of water as a 10 raised to 3 we can take. So 10 raised to 3 will get cancelled, and only the 8.5 will be left as a relative density. Now the third table. In the third table they have given to us weight, they have given area, they have given, and the pressure we have to find out. Weight they have given, so it's nothing but like the previous examples. In a solved example already they have taken. What we can do, the formula you can utilize. I'm giving only the formula over here. You can use a formula. Pressure is equal to weight upon area. So this formula you can use to solve the table number 3. You can try it. If you're not getting, you can post me, then I will give you the result for it. Let's go towards the question number 6. Question number 6, again same way. The density of a metal is 10.8 into 10 raised to 3 kg per meter cube. Find the relative density of the metal. What you have to do? You have to solve it like in the table we have done. Same way you have to do. Density of a metal they have given, and relative density they have given. What we have to find out is the density of a relative density of the metal we have to find out. So density of a water you can choose as a 10 raised to 3 kg per meter cube in this particular question. So if I want to solve it, so formula we know very well, that is relative density is equal to density of metal upon density of water. So density of metal, that already they have given, that is 10 raised to 8 into 10 raised to 10.8 into 10 raised to 3, and density of water is a 10 raised to 3, so this will get cancelled and the result will be 10.8 kilo. Sorry, this is a relative density, no, so no unit will be there. Only 10.8 will be the result for it. Let's see the next question now. Question number 7. Volume of an object is 10 centimeter cube and the mass is 50 gram. Density of water is 1 gram per cubic centimeter. Will the object float on water or sink in water? So if we want to find out that, we should know the density of the object, and for that we require a formula: density, volume and mass, that we can use. Mass upon volume is nothing but the density. So once we are getting a density of object, we can compare with the density of water. If object's densities are higher, then it will sink. If it is same as water, then it will be in a water and it will float. And if it is less than water, then it will float at the surface. So let's check it out for this one. We will use a formula. First, we calculate the density of object. Density is equal to mass upon volume. Mass they have given as a 50 and volume as a 20. 0 will get cancelled and this will become 2.5. So density is a 2.5 gram per cubic centimeter. So what we have now, density of object is more than density of water. Then at the last we have to write down the sentence: therefore object will sink in water, because density of object is higher than the density of water, so it will sink in the water. Now the next question: the volume of covered sealed boxes 350 centimeter cube. Volume they have given, and the box has a mass of 500 gram. Will the box float on water or sink in water? What will be the mass of water displaced by the box? Mass of the water displaced by the box will be equal to the volume of the box. So that is a 350 centimeter cube. If it's having a volume, you can see over here the volume of the box is a 350 centimeter cube, so it will displace a 350 gram of water. So that sentence you can write at the end of this. And about whether it will sink or float, first we will calculate a density like a previous question. First we will calculate the density, and then we will compare it with the density of water, that is 1 gram per cubic centimeter, and then we can decide whether it will sink or float like a just previous question. So this as an activity, what you have to do, you have to solve this and you have to post in the classroom. So this is all about the numerical and the chapter.